Hello students, in today's video let us see development process and the process model. A set of phases and each phase being a sequence of steps. Sequence of steps for a phase is nothing but methodologies for that phase. If so, then why do we have this kind of phases? It is to employ a divide and conquer. That is, you are not actually trying to solve a problem in one go. You're trying to divide the problem into sub-problems and trying to solve it. Next is each phase handles a different part of the problem. When we divide in such a way that one part handles one kind of problem and that is solved. So it helps in a continuous validation. That is, you don't have to validate at the end of the project, but as soon as you finish each part of it, you go on validating. The process model provides generic structure of the process. That is, you don't have to have a actual specific format for this. It provides a general structure by which you are actually following to have the rest of the projects that you have been doing or you want to do in the future, and to achieve their goals you are trying to have this process model. So basically a process models should be like this, or these things are included. Like what? We call that as a software development life cycle. So these are the things that is included. We have models, okay? Some of the models for this developing of software. But basically these models include what? First thing is the planning, which is the foremost and very important one. Without planning, we are never actually moving forward, okay? The planning. Next is the analysis, that is the requirement analysis. What are the requirements actually has been asked by the customers. So based on the requirements the customer has said, we design the project or the software, and after designing we code it accordingly, and after coding, in coding we all take the decisions of what language has to be used and what platform you are actually going to do it, all those things. After this is done, we do the testing. Coding can also be called as a development, and testing is done after that to see how accurately the program coded is working. And next, after testing, so it is ready for implementation, so it is installed in the system, and once the customer starts using the software, periodically it is maintained so that the software comes for the long run and it can be used with ease. So it has some of the phases as you've seen. Planning, so what activities are done in these phases we'll see. In planning, we define the system to be developed, we set the project scope, that is actually what is to be done, and develop the project plan, how the project will be moved forward or how it will be done. For this we have the requirements analysis next, that is gather the business requirements and the documented in SR. Okay, whatever is done, I told you all the things whatever you are doing in the software process or the process models, everything has to be documented in the sense you have to have a written copy of it, what you are actually doing. Why? Because it helps in seeing what next can be done, or if something goes wrong you can just refer back like what was done. Okay, so that is the documentation is a must. And next is the design. The design of technical architecture that is based on SRS, and the overall system structure is also designed in this phase. Next is the development. Development is nothing but actually coding. So it's a based on the technical architecture we have designed, we are actually building the software. It includes databases, programs, everything. And first in developing phase what is done is you actually divide the programs and divide the problem, and for that problem you try to find the solution, that is you code the small parts in small units, and then it is integrated together for the working of the whole project. When this is done, next thing is we do is testing. We write the test conditions and perform the testing. What are test conditions? It's like the condition on which you are testing. Okay, so what scenario you are using and testing, all those things are written in this. And after that, testing is done. When the testing is full-fledged, it's completed, it's accurate, whatever the answers you're getting is right, or the software behaves in the way that was required it to behave. When these things are met, the testing is done and the implementation part comes. That is, you are actually giving, or you are handing over your software to the customer, or whoever is the stakeholder who wants to use it. And what is done is write the user documentation for we are training him like how to work in this, like you have to give a demo, right, how the project works actually. So that is done. Then it is deployed in customer environment or released to the market. So customer environment in the sense, if somebody is asking it personally, privately, you ask. If somebody is asking, you're giving it to him. Otherwise, if it's like general app, like every common people can use, then what you are doing, you are actually releasing it to the market. Next is the maintenance. Every software has to be maintained, and even in your mobile phones there you get the option for updating it every now and then, right? So that is nothing but like maintenance actually. That is, you are trying to fix the bugs that are whatever is there in the system, whatever the problems arise when you're working or using that app or software. So any changes need to be made is made in this stage. And maintenance usually happens all along the software is being used. And you can actually have a help text, that is if some problems are there, they can just call the people who have made it. And if there are it should support corrections, improvements, adaptations, and support system changes. That is, system becomes obsolete, right? As I told, usually it's hardly 6 months of technology or a system remains, and later on it should be replaced. But sometimes we can use it even for a little longer with some modifications, only if the software allows for that options. Otherwise you cannot do it. So these are the things that actually includes in the SDLC. So next is the, based on this, we have some of the models and we have some names for that. The first one, we call it as a waterfall model. Why waterfall? You can see because it is a stepwise, one after the other, the water flows from top to bottom. That is why it's called the waterfall model. And one of the first process development model processed was a waterfall model. It's a linear in sequence, that is, I told you, in one line just it flows. And it requires first you have to develop design, or before that you actually have to have the requirements. And you are actually designing, then designing the system, then you're coding it, then testing it, deploying it in the sense you are actually giving it to the customer. A phase starts only when the previous has completed. That is, only when the water falls from this end to here, only it can enter the next one. So it cannot jump from directly from here to here. That is the point. Okay. And there is no feedback, like you're not going to test whatever is happening at the end in this phase, then you're not going, you're just going to the next phase. And it works well for well understood problems. If the problems are easy, you just need to have some you know um, programming done to the problem you're having. It's quite easy and it's easy to understand. And for that purpose, if you use waterfall model, it will work out. Okay. And each major phase is marked by milestones and deliverables. That is, in each phase it is written what is the end phase you get. Like you put something here and you get something here, and that whatever it comes in this end is put to next phase. That is the thing. So there is no much of complications in this model. It just goes on flowing. So this is typically how a waterfall model looks like. And students, remember, this is one of the very important questions that will be asked. And you need to, this is the block diagram, you need to know how to draw this without any mistake. And There is no much about it, but still the information that is to be written in the each phase or the in the each box, these are a very you know, that it should be very clear, and the same thing should be written. You cannot actually, you know, mix it up with one another. Okay, the way has to be like this. So basically, as I told you, waterfall model, so it is a, see, from this phase it goes to this phase, then it comes again to this phase, again it solves here and comes to this phase, and again it, the output of this phase come to this next phase, and here it gets solved, same thing happens. Okay, so this is how typically it looks like, but we'll see what actually is happening. So system feasibility and validation, that is whatever the program or system you're trying to build, that is supported. See, that is some, it is not something that, you know, that can something can happen in the future. So it's possible with the resources available in the market on this day. That is system feasibility. And you're validating it whether it is working or not. It's working, then it is a feasibility report you're giving. That is, we get all the you know, required technology or even the hardware parts, whatever is necessary, that we are getting. So based on that, you are testing, you are you know, getting the requirements analysis and project planning. Okay, based on the systems available or a hardware part available, whatever it is, based on that you are actually planning. Again, you're validating that, like, if hoping that if something goes wrong, then you need to actually check it again, right? So for every step there is a validation or verification. Once this phase comes out, or the result of this phase comes out, it's sent to the next phase, that is system design. So actually what is done, the requirements document has been transferred to this, and the project plan, that is the outcome of this phase, that is sent to the next phase. So that is system design, and once the system is designed, it is verified, like whether the things are working technically or logically, is it correct, all those things. Then based on that, system design is done and document. See, this is the overall design. Here again the detailed design is made, and again it is verified, and the result of this, that is detailed design document, is sent to the coding section. And coding, what they do, coding and verification has to be done. And after this thing, when the codes run, we call that as the programs. So programs are run, and for this, testing and integration is done. So once the testing and integration is done, the test plan and the test report is given for the installations. That is, every part of the system is working properly, it can be installed. Then installation report, how well the system is receiving the code or the software. And once the installation is over and it's successful, then operations and maintenance is the remaining thing. So this is one of the important questions that will be asked. You need to know this. So this is how it looks like: requirements analysis, system design, program design, coding, unit and integration testing, system testing, acceptance testings, and operation and maintenance. This is a waterfall model itself. So that representation of in the previous video can also be put like this, but in the exam point of view, that is the diagram you need to know. So why waterfall? We call it this model as because of the linear ordering. As I told you, if you here it is put like, you know, one below the other, but if you say in a linear manner also, it can be applied. That is, each phase should have some output, and that output must be given or verified and certified, and it is given to the outputs of the next phase. Okay, and the outputs of these you know, phases in this waterfall model, or first one is SRS, then project plan, then design documents, test plan, reports, and final code and supporting documents. So whatever it is, the models we are using, the advantages and disadvantages of every model is very important, because the disadvantages of one model is, you know, covered as advantages in the next model. But and at the same time, we need to know why these models are used for different purposes. What is the purpose of each model? So if you take up the waterfall model, the advantage is it's easy to understand and easy to use. Okay, and it provides a structure to inexperienced staff also. Like you don't have to be very well versed in developing this soft process to have this. So even an inexperienced person can handle this. And milestones are very understood, that is whatever the result you are getting, what result it is very easily understood. And requirements should be stable for this. Requirement should be stable in the sense a customer cannot come now and then and change his requirements. Once he has given the requirements and said this is okay, he cannot make changes as often as he needs. So that is why where a simple project where it does not require much of a technicality or logicality that is being used, these waterfall models will work well. And it's good for management control, like to plan for the staff what is required for this, or to track where the project is. It's very easy and works well when the quality is more important than cost or a schedule, because it's kind of slow. Like only at the end of the project you will get the project. In between you can never have this. Okay, so you should have like quality is more important rather than the time or the cost. If you see, then this can be an advantage. So when we have speak about the advantage, there is also a disadvantage. It's not it's no model is comes with only the advantages. It also has some disadvantages. That is, requirement should be known at the starting of your project. You cannot have the requirements adding up in between. Only when you're sure that requirements is only this much for this project, only then you can have this kind of model. It follows a big bang approach, that is all or nothing delivery to risky. That is, see, once you give a project to be done for the company, and they solve the problem for you and just develop a software, it's usually that they may change the requirements in between. They may want some other facilities along with the whatever they've given. So in that case, this of model does not work. Okay, big bang approach in the sense, once the project is done, only then it is delivered. Neither in between, the customer can come and see, or anyone else can just make changes in that. No. So once the requirements is done, only at the delivery stage the project will be done, and no intermediate phases for this. That is why it's called a big bang approach. And very document oriented, that is, at the end of each and every phase a documentation has to be maintained. There is no other way, so that you can just skip this documentation, because it's very crucial for the next phase in the system. And next is a software development as a manufacturing process rather than the creative process. That is, it is only focusing on just developing it. They don't want to be creative, nor they want to be fancy. They just want it to do as it was said, and no iterative activities and change management that lead to creating a final product. Final product cannot be changed in between. Whatever was planned in the beginning will be delivered at the end, and there is a long wait. You cannot just have it very quickly. So usage is, it have been used widely. It's suitable for the projects that where requirements is easily understood and the technology decisions are easy, like what what language we need to use, what platform you want to use. When these decisions are easy in that process, we can use this. And if you know the project is built before, and based on that itself you're building a new project, then it's easy to have this model. Next is the prototyping. So when we say prototype itself, it's like a sample, right? Prototype is nothing but a sample. So if I have to say it casually, you can say there is a example or the sample given to the customer. He sees it, and after that, whatever the changes is required, he can tell it to the developers, in the sense the requirement collectors who are the company is working. and then again the required changes can be made. Okay, so prototyping addresses the requirement specification limitation of a waterfall model. There is one more V model that is not actually required for you, but you could think of waterfall model, it's enough. And instead of freezing the freezing the requirements at the start, as I told you, what in waterfall model, all the requirements should be mentioned at the starting of the project. So that drawback is overcome here. So you don't have to think it at the starting itself. Even in between you feel like adding some of the requirements, you can just add it. Focus is here to quickly develop the model, and not concentrating on how well the programs have been developed. No, it's only about just finishing up the project. Okay, and when a little requirements is known, that is preliminary requirements gathering is done, you can just start away with the prototyping model. So this is how it looks like. In the first one phase, what requirement analysis is done, design is done, code is done, tested, and given to the customer to look at it. And if he has some problems, he can say that. And later, when it's done, the requirements process whole once is done, then again it is designed properly. Then whatever is then it's coded properly and again tested. So basic steps, they include identify the basic requirements first. As I told you, it's not necessary to give in all the requirements at the starting, but some of the main requirements you can do, including like what input you are giving and what output you need, and details. Some some minor details that you need you can be given. Usually, it's not that big deal of the details, and develop initial prototype, that is user interface first. Then the customer is given for the review or feedback. Later on, based on that, it is revised and enhanced, and project is developed. So this is how it looks. Okay, list of revisions, whatever the prototype requirements have been done. Okay, and that is the prototype design, again revision is done, prototype system again revision is done, then tested, then delivered to the to the customer. So allows repeated investigation of the requirements or design. It's not a one time it is not completed in one go, and it reduces the risk of uncertainty in the development. That is, if tomorrow a new technology comes also, it's not a big deal to inculcate that in this system. Next is the prototyping. That is what is done in this prototyping actually. The cost can be kept low. As I told you, here the thing is to finish it up fast and just finish off with this. So build only features that needs clarification. Then it's quick, so may not be that complete or perfect. And exception handling, recovery standards are omitted. That is, only what is needed is done. We're not developing a software in such a way that it's very perfect and very much foolproof. No, you're only interested in first finishing off, then later on these things are done. Okay, and cost can be a few percent of the total. And learning in prototype building will help in building the improved requirements. So if we take the advantages, requirements will be more stable. Requirements are frozen later, not at the starting. And experience helps in main development. If the developer is a very experienced one, it helps. Disadvantages, it like hit on the cost and schedule. That is, time will be required more because customer has to review it every now and then. His time is also like kind of lost. And the cost you cannot say because you have to develop and again you have to see if it's working, not otherwise again it has to be developed, so cost will be a little high. So where these kind of models can be applied is when the requirements are hard to find it out at the starting, and um, the confidence that you have in these are the requirements that is low, you can think of this prototyping model. And if the requirements are even not well understood, this type of prototyping is done. Next one is the iterative development. So as the name says, iterative in the sense one after the other, you can say. So it solves all or nothing drawback of waterfall model. It combines the benefit of prototyping and waterfall models. It develops and delivers the software in increments, that is not in a one go, so one by one, as I told you, one after the other, and each increment is complete in itself and can be viewed as a sequence of waterfalls, and feedback from one iteration is used in the future iterations. So this is how it looks like. See, once it's a zero phase, design is done, implemented, analyzed. If this works properly, again second design is done. That is the first, like number one. So design one, again implementation, analysis. The result is again sent to the next iterative phase. So this continues until any number of iterations you need. Okay, so based on that, this model is done. So what actually happens? Products almost always follow it. The software what is developed is usually following this method and used commonly in customized development, where the customer gives his software like what he needs for his business or whatever it is, and it cannot afford the risk of all or nothing. That is, either everything works or everything does not work. You cannot have that, because it's a business software mainly used for so that is why it has its own advantages and requirements. So never approaches like XP, Agile, or rely on the iterative development. So benefits is get as you pay. um, Feedback for the improvement is given, only then the next phase is done. Drawbacks is architecture design may not be optimal, that is rework may increase, total cost may be more, because you have to design in every time a customer asks for it, you have to develop and again deliver it to him. So it's a kind of a long process, so the cost all increases. And where it is applicable, where response time is important, all requirements are not known. Response time is important. So like, as soon as they have asked for the response, you need to get that. And all requirements are also not known. In that case, we are going for this iterative development. Thank you.